Okay, now very brief review of how we can write a function as a power series. Basically, there's two methods. One is to use the geometric series formula, and we know that 1 over 1 minus x is the sum of x to the n for n equals 0 to infinity, provided that x is less than 1 in absolute value. Now we can use this formula if we see x replaced by some other quantity, but also if we are working with functions that can arise as derivatives or integrals of functions that look like this. What are some examples? 1 over 1 minus x, everything squared, that's kind of the derivative of this. ln of 1 plus x, which is sort of the integral of functions that look like this. Or again, arctangent, which is also the integral of 1 over 1 plus x squared, which also is in this form. So all of these we can express as the derivatives or integrals of certain geometric series. So that's the first approach. If that doesn't work, if it's not one of these simple functions, then there's a general formula, which is the Taylor series formula, which allows you to express a function as a power series centered around any point a, and the coefficients are going to be the nth derivative evaluated at a divided by n factorial, and then you have times x minus a to the n. So here I'm writing down the first terms. When n is equal to 0, there's no derivative, that's just a function, and 0 factorial is 1. X minus a to the 0 is 1, so you just get f of a. When n is 1, you get f prime of a times x minus a. So this is called the first Taylor polynomial. Notice that you should know that this is the tangent line. Then I have f double prime of a divided by 2 times x minus a squared, and so on and so on. But if we want to use this and write down a closed formula, then we should figure out a general expression for the nth derivative at the point. That's not always going to be easy.